In this video, we're going to look at composite functions and inverse functions. One kind of leads to the other. You can certainly find a composite without finding, using the idea of an inverse and vice versa. In Chapter 2, in Section 6, you'll also look at the algebra of functions, some difference, product, and quotient, which is basically what you did up in Chapter 1 and in Chapter P, where you did some work with polynomials. So that's really the same thing that you did before, just now we're going to use some function notation and put that on as part of it, where you have f of x and g of x. Much more interesting is the idea of the composites. And what a composite does is basically takes one function and puts it into another. So I'll have one thing that I'll have to do to crunch a number, then I'll take that and then I'll put it into the other one. You can kind of think about it as a two-step solving process. And we also have two different ways that we can write it. We can have this lovely fog-looking thing where it's f of g of x, or we can use this f of g of x, and they both say the same thing. You kind of read them from the inside out, or for the end backwards, where it says take g of x, everything that's g of x, and plug it inside of f. You can also put f into f and g into g, and you can kind of move it around a little bit. I don't really worry so much about, what's the domain and what's the range of these types of things. It's a lot easier to actually find the composite function, most likely, and then start to look at what type of function domain and range that you have. So I have two here. I have an f of x and I have a g of x. And what you'll do in my math lab is basically you'll find a, b, and c. You're going to find f of g, you're going to find g of f, and then it says like find f of g of 2 or f of g of -1 or something like that. My f of x is a 3x plus 2. G of x is an x squared minus 1, which means basically if you have a square going one of these directions is going to be a little more complicated. And that is going to be the f into g. So a is going to be the easy version and b will be the little bit harder. So with a, what we're going to do is we're going to take all of g of x and we're going to shove it into the f function everywhere you see an x. So I'm going to take this x out and plug all of that in instead. So f of g of x is, instead of 3 times x, is 3 times x squared minus 1. And then I'll clean that up by distributing it and then combining like terms. So that f of g of x is a 3x squared minus 1. Not so bad, right? Going the other way is going to be a little bit more interesting, because I was hoping to make that smaller, but I guess that's not going to work. Let's try this. There we go. I have this lovely square, so that's A. So now I am going to do the exact opposite, basically, and I'm going to take all of F and plug that inside of G. So I'm going to take all of this, and anywhere I see an x over here, I'm going to take the x out and plug all of that in. But that x was squared. So for B, g of f of x is going to be, instead of x squared, 3x plus 2, that quantity squared minus 1. So I'm going to need to FOIL this, because that says 3x plus 2 times another 3x plus 2. And I got this minus 1 floating around on the outside. So we'll have to do this algebra of functions in here, right? Our FOIL, or multiple distribution. I'll get a 9x squared, a 6x, another 6x, 4, and then I got this minus 1, and I can go ahead and combine like terms for a 9x squared plus 12x plus 3. So not too bad. These can get super ugly because it doesn't have to be linear and quadratics. It can be any kind of terrible looking equation and expression, but usually they try to keep it to a low raw and it's not too overwhelming. I'm going to group this and make him a little bit smaller. Now usually the C part of my math lab is it takes one of these and says, okay, now plug a number in. So now with function notation, if you have a number inside the parentheses here, it says take the 2, go to this function and plug it in. Well, we have f of g of x right here. So what I could do is just go into here and say, well, this is f of g. Let me just go ahead and shove a 2 in there. Crunch that number, and I'm good to go. Now, if you don't already have this part worked out, and you still have it as it's separated as f and g, you can still find what you're looking for. What you'll need to do is exactly what we just did here, but in the 2 steps. We'll need to take this 2 and plug it in to g, and then take whatever that is and plug it into f. So for this, you would say, first, let me take the 2 and plug it into g. So that's going to be 2 squared, which is 4, minus 1. There's our 3. Okay, now take that 3 and plug it into f. And f is 3 times 3, which is 9, plus 2. It's like magic. It's 11. Same exact thing. So if you can do it in 2 steps if you don't already have the algebra, but if you do have the algebra, then you can go ahead and just plug it right into this. Either way is the exact same thing. Totally fine. I don't think the calculator will be really any help for you with this type of thing unless you have crazy decimals or something like that to crunch. There's no composite function button, unfortunately. There is also no tell me the algebraic form of the inverse. Now, the reason that inverses and composites kind of go hand in hand is because what an inverse does, or actually it's about what it undoes. It undoes everything it did before. Now, if you look at your handy-dandy calculator, okay, that's a little big, but it will get the job done. It's kind of set up to work in inverses. I have the x squared. How do you undo a square? You take a square root. Later on, you'll look at logarithms and ln's. Well, a log undoes an exponential. And so these guys are inverses. You got that little -1. This is sine, cosine, tangent. They're trig functions. This is inverse sine, inverse cos, inverse tangent. And so all of those guys kind of go together. Again, this is not going to help us much, so I'm going to go ahead and exit this. And let's start talking about how you find an inverse. Let's say I have the function. Let's take a nice one, like 4x minus 1. And what it will say is like, find f inverse of this function, where that little -1 is kind of shoved in here. It's really only 2 steps, which is a little deceiving because it can kind of get ugly, depending on what kind of expression you're working with. What you're going to do is swap x and y, and then you're going to solve for y, which seems kind of silly, right? You think, whoa, I'm just going to wind up with the same thing. And you actually wind up with the exact opposite. So if I have f of x is equal to 4x minus 1, that's just another way of saying y, right? F of x is just a fancy way to say y. So I am going to swap these 2 guys. So now I'm going to put the x over here, and I'm going to put the y over there. And I am going to solve for y, which means I'm going to have to add 1, and then divide both sides by 4. And the easiest way to do it is just kind of do the whole chunk at once. And so what you then get is the inverse of x plus 1 all over 4. And you could see before we were subtracting 1, and now we're adding 1. Before we were multiplying by 4, now we're dividing by 4. Everything is the exact opposite of what it was before. If you take one and you form a composite with the other, like this, it looks really ugly when you write it like this. But if you take f inverse and you plug it into f, or you put f into f inverse, what's going to happen is, well, this says subtract 1, this one says add 1, this one says multiply by 4, this one says no, divide by 4. Everything f says to do, f inverse is like, nope, do the exact opposite. And so your answer will always be just x. So what you can do is verify if two functions are inverses by forming a composite. So like x minus, let's say x plus 2, I'll put a 3 out here, and then I'll put my other guy be x minus 2 divided by 3. And I know this looks a lot like the other one, but I just kind of want to prove a point. That's f and g, and I say, is g the inverse of f? Which said nobody ever, right? But let's say if for some bizarre reason somebody wanted to know this, you would say, all right, I'm going to take all of this and I'm going to plug this into here. Let's see what happens. So instead of 3 times x, I got 3 times x minus 2 over 3 plus 2. Well, 3, then this divide by 3 down here, he goes, right? We just cross divide. And I get x minus 2 plus a 2. Well, those go, and you're left with just x. And when you're left with just x, your answer to this question will be yes. Indeed they are, because everything I said to do before with no leftover, I get the same thing back. One that's a little bit more interesting maybe is, let's say, find the inverse of, maybe we can find a weird one in here, inverse functions. Oh, there we go. Let's take him. So here's this lovely item, and we want to find the inverse. This is probably one of the more difficult ones, actually, because your x is stuck on the bottom. So now, of course, f of x is just a fancy way to say y, so we get rid of him again. And let's swap x and y. So my x is going to come out here, and my y is going to come down here. And I want this, when I'm done and I have found the inverse, it will say y equals again. So I'm going to add the 5 to both sides. And I have this. Now, you kind of have two ways that you can go about this. You can flip it, since you really just have a proportion, and say, oh, I'd like the y to be the other way around, so if I flip him upside down, I can flip him upside down. And then I can multiply both sides by a 3. Now, honestly, this is something, I've been teaching college algebra for what seems like forever. Nobody ever thinks of this. But now that you've seen it, you know you can do that. When you have a proportion, a fraction equal to a fraction, you can flip those guys right upside down. But if you flip one, you got to flip the other. That's the deal. Imagine like they're like on a rotisserie wheel, right? So if you flip him, you got to flip him. But nobody ever thinks about that. Usually people see this and say, oh, well, I'll cross multiply. And I got y times x plus 5 equal to 3. Don't distribute. Take this whole big chunk. Remember when we were doing literals, right? And we didn't distribute? Do the same thing. And you got y equals to 3 over x plus 5. Same thing. And that guy is your inverse. Your calculator will not find an algebraic inverse for you, so that's just kind of something you have to do on your own. It will graph it for you if you know the original, but it's not terribly exciting. That's how you find a composite and how you find an inverse.